The reason that I'm showing here is I will help you construct this Excel table step by step. But before constructing this Excel table step by step with all this formula, you can design your own Excel table where you just enter the values and you will get the Gauge R&R reading. Second thing is, there is no need to always learn this. It is only people who are academically interested can understand how to construct this. There is no need to construct all the time. Okay, fine. Let me play this video. The steps in MSA, measurement system analysis, step by step. Now, to show how to conduct a gauge repeatability and reproducibility study, we are going to walk through the steps of conducting this. Now, this is called a vernier caliper or a digital caliper. Step one is to collect 10 parts that span the specification limits. Make sure it spans the specification limits. N, D, C, number of distinct categories. What does it mean? I'll tell you so that you will not have to worry about that. Suppose if I am making cookies between 10 to 11 grams, okay, there's a specification limit. Now, if I take cookies only between 10.5 and 10.6, some 10 pieces, it is wrong. My specification limit, that is the weight of the cookie, is 10 to 11 grams. Suppose all the cookies that I have is weighing between 10.6 to 10.5, 10.5 to 10.6. Then what happens is, you will not be able to infer whether it is a repeatability issue, a measurement issue, or process issue. So for measurement system analysis, do not worry about whether the process is capable or not. Take the samples under entire specification so that your device is able to detect 10 grams also, 10 to 10.1 grams also, 10.3 to 10.4 grams also, 10.6 to 10.8 grams also, and 11 to 11.1 grams also. Something might be outside the specification limit. So these are all called distinct categories. So there are 5 distinct categories, okay? Samples which are between 10 to 10.1, samples which is between 10 to 10.3 to 10.4, samples between 10.5 to 10.6, samples between 10.8 to 10.9. So there are 5 distinct categories. But it's very important that the number of distinct categories should be more than 5. Sir, how do I know number of distinct categories more than 5? Can I specifically select the samples? No. When you put it in the software will detect how much categories are there. When you put it in the formula will detect how much categories are there. If the number of distinct categories is less than 5, do not even go ahead with the studies. Do not even rely on the outcome of the study. Okay. Now the question is, why should the NDC be more than 5? In mathematics, there is something called as a theorem and proof. And people test hypothesis. Statistically, they research and help us with a formula, help us with a guidance. Later on in process capability, we are going to talk about p-value. And we will say that if p-value is low, the null hypothesis should go. Okay. Don't rely on your hypothesis. And p-value should be less than 0.05. Why should it be 0.05? Okay. Now, before questioning that, we can do a research in mathematics, but that's not the intent of this exercise. There are some norms, thumb rules that are set, and we will follow that. If objective is not to show the theorem and prove why it should be less than 5. Okay. So we are going to use 10 bolts in this example, and depending upon how you set up the Gauge R&R, this typically conducted with 3 operators. Okay. Now, 10 parts are there. As you collect your 10 parts, it's very important to make sure that the 10 parts span across the entire specification. Okay. And you actually have defective parts also, it's okay. That is, which is beyond the specification. You should make sure that you have enough resolution within your range to detect the good parts and bad parts. Okay. Like for example, we have spoken about the resolution. We call the scale also, we showed the resolution. So you should have enough resolution to detect the good parts and bad parts. Now, step 2, the number of parts. Once we have our 10 parts, it's important to make sure that we number the parts. For these parts, I have 10 parts. We are just going to number this through 1 to 10. So set up the chart to record the results. So this is a Gauge R&R chart. We typically use a format like this. You write the gauge name. You have operator 1, 2, 3. Okay. This is 10 different parts and 3 different operators. Each operator will conduct 2 trials. This gives him information about repeatability, and reproducibility is between the operators. So let us fill the header of this chart. Digital caliber, gauge number, date, and all that stuff. Name of the gauge might be different in different cases. In this case, we use a digital caliber for this example. Now we need to randomize the result. What does randomizing result means? Like you have 3, it is important when we go through and we start actually measuring the parts, we need to think about the order. Let me explain to you this. There's something called as a bias. If I know that the same part is coming, I have already measured that part, I will tend to think that, hey, this will be the same reading, and I'll try to bias my reading. So, though I have numbered the parts, I'll give these parts randomly to the person, and whatever reading he says, I will only note down. The person who actually tells the reading, I will note down. I will randomly give him the parts. And so in this way, in Minitab, there is an automatic way to randomize this. I will teach you Minitab in the probably coming session. It will randomize, instead of telling 1 to 10, it will randomly say, okay, pick the second part first, 4th part next, 8th part as a 3rd one, and so on and so forth. So this is primarily to prevent the bias. So we wanted to avoid the bias, and that's why. In addition, it's also important as we run this, we have 3 different operators, and those 3 different operators is recording the data. For example, if you go through the measurement of part 1 and we measure the part 1 again, then there'll be a bias. So human nature is too. So we want to avoid that. So we want people to actually get the reading without the bias from the learning curve or knowing what the previous reading was. Like this, randomly pick 3 first, 6 first, 5 first, and so on and so forth. If you want, there are some people also use this. Earlier we have used this. We use some, there are also apps to generate random numbers. You give between 1 to 10, you know, and then it will tell you pick the 9th part, pick the 1st part, then pick the 5th part, and so on and so forth. Okay, now after randomizing this, we have measured these random parts like this. So here you can see that they are measuring that and recording that reading. And they are picking that part which is randomly generated. And then we have this recording sheet. where we record the reading. So step 7 has to be repeated. And so you repeat this using this randomized. So let's go to step 8. For operator 1 to 5, we enter this. So operator 1 has completed that. So he has completed the trial 1. So the operator 1 should repeat this entire trial. And same randomization method should be used. So once the operator 1 is done, we go to operator 2 and operator 3. Okay. So similarly, in total for this process to conduct it, you actually need 4 people. 3 operators that are performing the gauge and R&R and 1 person who is recording the data that is being conducted. So last 2 steps. So everybody gets a different feel of the gauge, and that's why 3 operators are taken. So at this point in time, we have completed all the gauging for all the parts, and this template is now ready